Hello dear students, welcome you all to the Sri Chaitanya Educational Institutions Goshala YouTube channel. In this session, in the subject chemistry, I am going to give you the elaborated or detailed solution for the questions which were asked recently in NEET examination. Alright, so these sessions we are going to learn how to solve the questions on the previous NEET examinations. So I am Dr. Pawan Kumar Kasu, will be helping you in enriching your subject knowledge in chemistry. And Sri Chaitanya will be discussing these questions in all four subjects, that is botany, zoology, physics and chemistry. If you look at the last few year question papers, one point is pretty clear, that the questions which are asked from chemistry are not the easy ones. Like if you see last year analytics of the question paper, you will find majority of the questions were not straight. At the same time, those questions are basically statement oriented. So if the question is statement oriented, you need to have a lot of endurance to read them, to assess each and every statement which is given, and to understand whether you have to go for that option or not. So it's not going to be so easy to solve these questions in a stipulated time, that is 1 minute or 1.5 minutes. For that, you require to have the correct approach to the subject. And I hope these sessions during the slag hours of your preparation would certainly help you in nurturing your preparation and pack up the speed. So let's see one by one what are the questions that are asked. Every day I intend to discuss at least 20 to 25 questions, give you the detailed solutions and related theory. Let's start, students, with the questions, and before that I would like to announce this for you. Look at the timings and make yourself available. Alright, if you are eyeing at a good rank, you must be thorough in all the subject, especially physics and chemistry. Alright, so look at the questions that were asked previously. Look at this. It is purely statement based question. Alright, now select the correct statement. One thing we need to be sure about is whether you are asked the correct statement or incorrect statement is very important. Alright, correct statement. This question is from the structure of the atom. Looks to be an easier one, but be careful, especially while reading the sentences. Alright, first statement: atoms of all elements are composed of two fundamental particles. Alright, you all have studied at the beginning of the structure of the atom itself. What? That the atom consists of three fundamental particles. They are electrons, protons and neutrons, collectively present in the nucleus called as nucleon. So electrons are present in the extranuclear part, however the protons and neutrons are together inside the nucleus, hence called as nucleon. So total number of fundamental particles, the fundamental question, fundamental statement, the basic statement, right? So total number of particles, fundamental particles should be 3, however it is given as 2, hence this is not correct statement, isn't it? Next, the mass of the electron is 9.1 into 10 to the power minus 31 kilogram. We have been studying, isn't it? The regular mass of an electron is this much. Alright, so this is a correct statement. Alright, whereas if you have to find out the mass of the electron at some other velocity, you know, you will be using this formula, isn't it? But since the rest mass is being mentioned, so we consider this as a correct statement. Alright, so B is correct. All the isotopes of a given element show the same chemical properties. Isotope, you know, you have studied isotope, right? Same atomic number, different mass number. Alright, so they show the equivalent or identical properties, isn't it? For example, if you are comparing the properties of what you call H2O and D2O, you have seen that though the isotopic substitution had differed, for these two compounds, the reactions are similar. For example, you know that water, what you call, carries out the hydrolysis on SiCl4 to replace the all chlorine atom by the OH groups, and subsequently that converts into the oxide. Likewise, you could anticipate here the same thing to happen with D2 also. And you have also studied the properties of H plus could be correlated to the properties of D plus when it comes to the acidic property. Or you know that hydrogenation like reaction can be carried out with deuterium also, right? You can carry out what you call the syn hydrogenation on an alkene by using hydrogen as well as the deuterium. However, the product would slightly vary. Deuterium comes instead of what you call the hydrogen atom. However, the properties are similar, the way they react are similar. So you can see that all the isotopes of the same element show the similar chemical properties. C looks to be okay. Protons and electrons are collectively known as the nucleons. It's a wrong statement. As I said at the beginning, that protons and neutrons are collectively called as nucleon. This you have studied during your school days only, isn't it? Now let's move on to the next statement, the Dalton's atomic theory, the basic theory, the starting theory. John Dalton is the one who had described the atom as smallest undivided constituent part of the matter, right? Regarded as the ultimate particle of the matter. Yes, it is the starting part. Before further investigation was done, it was all about the atom. All right, so this also looks to be okay. So three statements which are correct are mentioned in option D. So we need to be careful while reading these options. That's all right. So please be careful while reading the options, isn't it? All right. So let's move on to the next slide. Look at the next slide. This question is basically from chemical kinetics, and it is about the collision theory or Arrhenius equation, which is your favorite part of chemical kinetics, isn't it? That theory says that increase of temperature increases reaction rate. All right, and we also study about the activation energy. All right, so when you study the variation of the rate of reaction with temperature by studying the Arrhenius equation, you would mention that as what? K equal to A, that is frequency factor, exponential of A upon RT. So there is an exponential relationship between the K and temperature. You know your favorite equation, isn't it? Now listen to me carefully. The statement says, if you have to solve this question, you have to understand the statement clearly. So this says that reaction can have zero activation energy. What if it has zero or negative activation energy? Let's understand this, right? So when I substitute here the activation energy, the EA value as 0, so what this would become? A into E power 0. The whole thing will become what? 0. Then E power 0, the something power 0 is 1. So K becomes equal to A. All right, that means what? K, that is rate constant, denotes the fruitful collisions, effective collisions. All right, so K denotes the effective collisions. However, A denotes the total collisions. We are talking about here what? Effective collisions versus total collisions. We need to understand that the effective collision can never be equal to the total collision. That means cent% conversion of all the reactant molecules in a stipulated time to the product is not possible. Only a portion of it will undergo what you call the product formation, which is represented as K by A, which is nothing but Boltzmann factor. So 100% conversion of the reactant into product is not supported by what you call the Arrhenius equation. So K can never be equal to 100% of A, nor K can be greater than A. Therefore, in order to what you call rule out this statement, we cannot substitute the EA value as 0. So activation energy of a reaction can never be 0. It should always have some positive value. It cannot be 0 or negative. So looks to be that this assertion is wrong, isn't it? Now look at the reason. When it itself is wrong, the reason doesn't make any sense unless it's a true statement. You can see the minimum extra amount of energy absorbed by the reactant molecules, so that their energy becomes equal to the threshold value is called as activation energy. It's something like this. What's happening here, please understand. This is energy and this is reaction coordinate, something that varies with time. Normally distance between the molecules is taken on the x-axis. As the reactant molecules are colliding due to the fruitful collisions, so this is where reactants are, this is the product. Reactant has its own energy known as average energy. Alright, this is possessed by the reactant molecules. Alright, and due to the participation in the fruitful collisions, it is reaching the energy barrier, the highest energy state. This is called as threshold energy. So this is threshold energy, this is average energy. So the molecules which are not able to reach out to the threshold energy, it's something like this. Some students inherently have their own merit. Some students are acquiring that knowledge by self-study, and those who are not able to do it are being given some extra push, and that is what you call as activation energy. Alright, that is what you call as activation energy. That extra edge, like I am giving you right now over the online platform, that is nothing but the activation energy. So that statement looks to be alright, isn't it? Perfect. So reason correct, assertion is false but reason is true, looks to be alright, isn't it? Okay, so assertion is false but reason is true. Alright, so you have to actively participate in the session. Alright, can we get 180 from this series? Yeah, I would anticipate that you get 180, Komal beta. I wish you good luck, and I am sure that during this tenure of the last few days, these lectures would certainly help you. This is something like activation energy that I am providing you with. You already have the average energy, and by virtue of your preparation, आप थोड़ा सा threshold energy पा चुके हैं, and whoever is not able to reach out to the what you call mark, we will help you here. So please ask your subject related doubt, and please stay tuned with me and try to answer these questions. And if you are getting the answers to these questions without my support, that means you are very much in the race. Alright, so wish you good luck. Shall we move on further? I think you guys are understanding exactly what I mean to convey. Alright, so let's see. Solid state, little bit scary, isn't it? That's what I said, Komal. Hope you understood and you'll prepare well, and for that you need to concentrate, right? A compound is formed, solid state questions, you require to have little bit of imagination power, isn't it? Little bit of visualization. You have to assume the room in which you are sitting as a cube. Look at the corners, look at the face centers. Let me brief you. If you take this structure, you can see the element B. Alright, so you guys can see that B is forming cubic close packed structure, which is nothing but what? CCP, the closest packing in cubic unit cell. Closest packing in cubic unit cell. If you look at the packing fraction values, you know you have studied, isn't it? Solid state deleted Varshini Reddy, but what to do? This is a previous year question, so it's part of this thing. Hope it will help you in other entrances like CETs. Alright, and these questions are recently asked in EAP CET, that is otherwise called as MSET. So let's discuss this because it's part of the previous questions. Alright, exactly what you said is right, Varshini, but not for NEET. Yes, for NEET it is deleted. but for baki sare it is there. Okay, so let me discuss. All right, nothing more complicated here. If you are preparing for the other entrances also, this should help you. It's not very complicated. Let me explain this. All right, so CCP, in a what you call cubic lattice, you have simple cubic. Let me write all the lattices at a glance. Then you have body centered cubic, and then you have face centered cubic. There are three lattices that you have studied, isn't it? Small topic, so let me quickly wind it up. Now look at the packing fraction of simple cubic, 0.52, 0.62 and 0.74. That indicates that 74% of the cube in face centered cubic is occupied by the spheres, 26% void is there. Similarly here it is 62% packed, 38% void and all that. So closest packing, that means the atoms are tightly packed in FCC. So FCC, face centered cubic, is nothing but what? CCP. This thing we need to understand first. And you know, in FCC, you guys can see that in FCC the lattice positions are what? Corners. The atoms are present at the corners and also face centers. Alright, FCC, the name itself indicates, isn't it? And you know how many corners would be there? 8 corners, but each corner is common to 8 unit cells, right? That corner you are looking at, you are sitting in a room, look at that corner, it is common to 8 other rooms. 4 in the plane where you are sitting and 4 on the top. So total it is common to 8 other, total 8 unit cells, so 8 into 1 by 8. And faces is your opposite wall, like this wall is common to this room as well as backside room. So it is contributing only half. So total number of spheres in FCC is 4. This you otherwise call as rank. So you can see what is forming the closed packed structure, B. So B is 4. And A atoms, 1/3 of the tetrahedral void. You know tetrahedral void, you know octahedral void is equal to the rank, and tetrahedral voids is double the rank. Remember this. Octahedral voids is equal to the rank and tetrahedral void is double the rank. So you can see tetrahedral void, which is occupied by A, is how many? 1/3. 1/3 of 8. Now when I am striking this off, you can see the common factor 4 is there. You guys can see, right? So this will become what? A 2 by 3 and B. Otherwise you can write it as A 2 B 3. And you have been asked to find out the value of x plus y. So you can see clearly that x is equal to 2 and y equal to 3. So x plus 5 is obviously 5. So isn't it simple, Varshini, Srijoy, Komal? But this is not so complicated, isn't it? But if by chance question is asked in the other entrances that you come across, you should not stay blank. That's the reason why I had to discuss. Hope you guys have understood. Alright, okay. Chalo, we will move ahead. We will solve some more questions based on this. Metallic sodium, frequently asked question. This topic plays a significant role for the reason that it comes in what you call the 1A group elements, right? Now don't say that 1A group elements are also deleted. Thank you, Timothy. Low voice. Renuka. So you can't hear me properly. Now am I audible, buddy? Can you hear me, buddy? Yes. Chalo, stay with me and I'm going to teach you some fabulous things. Right? Listen now. Metallic sodium dissolves in ammonia, giving a deep blue color solution. We had anticipated there that the deep blue color forms because of the solvated electrons. You see, this whole process of dissolving the metal in ammonia or water can be divided into 2 phases or 2 stages. Let me explain this. Now, are we saying that 1A is deleted? But ammonia is there, no? Haro. If everything is deleted, what do I have to discuss, right? Ammonia is there, do you agree, buddy? Ammonia is there. So let's discuss in that context. All right. Okay. Chalo. For the sake of ammonia, let's discuss. So sodium, because this topic is related to what you call ammonia only. You guys can see, right? Amide. All right. Amide is nitrogen. And don't say that p block elements reactions are also deleted. Then I would say, but a color properties of the compounds is there. So something or the other is there, right? So when you look at this, you have Na plus and electrons. All right. Now these electrons would act as the reducing agent to convert this ammonia into NH2 minus and hydrogen gas. So the whole story will elapse by the conversion of this ammonia into amide and hydrogen. There is nothing wrong in saying that amide is formed, but it is wrong to say that amide is responsible for the color of this substance. You guys can look at here, metallic sodium in liquid ammonia giving a deep blue, which is paramagnetic obviously because free electrons are paramagnetic. Correct, isn't it? But the deep blue color is due to the formation of amide is wrong. It is due to the solvated electrons. All properties are due to what? Solvated electrons. You know, people wonder, sir, what are solvated electrons? Solvated electrons hote kya hai? You see, when these electrons are found in the protic solvent, they suddenly gain the energy or momentum. It's like, you know, you are going to retaliate against to someone in a conflict, in a spat. Like, you know, you are going alone, you will be beaten to the dust. But whereas if you are going with bunch of friends who are exactly like you, then you appear to be powerful, right? Then you appear to be, once again, low voice. Renuka, please, I think the others are not facing the same problem. I think this is the problem recurring with you. Hence, I suggest you to check your voice settings once. Is it the problem persisting to the other students also? So that I can ask my technical person to set right. So please check your device once, buddy. Renuka. Oksar ni device chusko beta.
I can check.
Okay, anyways, I am checking myself. I think it's okay. Done. From my side, it is okay, my people are saying. Alright. Renuka. Can you hear me? Varshini also feels low voice. Can we do anything with this? No. Alright. Perfectly alright. Working fine. Please check your voice once. I'll try to speak as loud as possible. Varshini.
You speak loud.
Ah. Are we saying please volume up, guys? And I suggest you, buddies. And also I'll try to speak in a louder pitch. Okay?
I can check.
Can you hear me now? Am I audible? Is this okay now? Renuka and Varshini, could you please say something? Okay na Tallulu? Yeah. Chalo, good. Good that you are actively participating. Hope this session goes well, right? Now listen. Here, that's what I said, Timothy, that electron when is single, it's not so strong. When electron is cohered by the ammonia molecules, when electron is surrounded by ammonia molecule which is also having the lone pair of electrons on it, it forms a cluster and appear to be the reactive one. That's what is the power of what you call the solvated electrons. And solvated electrons are actually responsible for the reduction reactions. Sodium in liquid ammonia is a good reducing agent, not because of amide, it's because of the solvated electron. डरावने लगते हैं, they are very scary. They are threatening the others. You see, I am coming with all the ammonia molecules. मेरे पीछे कौन है मालूम तेरे को? This is what each solvated electron says, right? So that's how we prescribe the solvated electrons to be the strong reducing agent, to be appearing colored, blah blah blah. Therefore, it is not due to the amide ion. So this reason looks to be incorrect. Assertion is true, reason is false. You need to answer with me, isn't it? Next question, easiest question. we study in chemical bonding, our favorite chapter, isn't it? You guys can see that amongst the following, the total number of species not, see, in a haste we actually miss out these things. Which is not, which is. I think you can hear me, Timothy. The problem is we are sitting in a heterogeneous environment. Exam hall. We are afraid of exams. We are worried, concerned, panicked, stressed out. And in that stress, you tend to not to read the question properly. When I am watching Virat Kohli playing, I feel every ball can be hit by me to a boundary. But in reality, it's not possible. You know that how complicated would it be to deal with that pressure situation. But why don't you understand? During that pressure only, at that extreme pressure only, the water droplet converts into the pearl. Neeti bindu mutyam laga maripotadu. Isn't it? So pressure has to be converted into the output by dealing it softly, without stress. Pressure is there everywhere. Without pressure, earth cannot survive. We require some pressure to survive. But pressure should not be destructive, dilutive. You need to understand. Not, you can see the question, species is not having 8 electrons. Octet theory. Alright, you know ammonia. How do I know, sir? It's very simple. Valence electrons plus number of bonds. Simple. Valence electrons of aluminium are 3 because it belongs to the 13th group plus 3 bonds. Beryllium second group plus 2 bonds. Carbon 4th group plus 4 bonds. Phosphorus 5th group plus 5 bonds. This is how we predict, isn't it? What do you all say? Renuka? What do you say? This is how we predict octet, no? Can you hear me, Renuka? Yes. Octet prediction is very simple. Valence electrons plus bonds. Haru, what do you say? Simple, isn't it? So this is how you can see that not having, how many species are not having, you guys have to be careful. So you can see these 3 species are not having 8 electrons in the valence shell. 3 species are not, AlCl3, BeCl2 and PCl5 also. So Renuka, yes beta, I think you have marked the ones, isn't it? Yes, that's a mistake. That's what I have been insisting, isn't it? Good. Anyways, good job. You guys are with me, very much with me. See, polymerization. Alright. Polymer is a very important compound, isn't it? Without polymers, nowadays it is difficult. PCl5 is hypervalent. Good. Could you please mention another example of hypervalent category, Haru? I want to hear this from you, buddy. SF6, IF7, isn't it? SF6, IF7, XeF6, XeO2F2, xenon compounds. Very good. Alright, hypervalent. More than the requirement sometimes we eat. That's what is hypervalent. Okay, so listen up. Polymers is an important chapter, isn't it? Yes, buddies. And you know what happens here? Neoprene, chloroprene, isn't it? Vulcanization of rubber. All these are very important. Rubber industry is very booming industry in our country right now. We are one of the largest exporters of rubber. And in our country, Kerala is known for the rubber exports. Important one. Yes, you are right, Haru. CLF3, that's a brilliant example which you gave. So what will happen here when I take n moles of the 2-chloro 1,3 butadiene, it undergo polymerization. How? The second mole and this one undergoes 1,4 addition. That means addition will take place at 1 and 4 position in all the compounds in which there is a conjugation, right? You can see that this is a conjugated system. So what will happen to the double bond? You guys can see the double bond had shifted over here, and this head and this tail would get connected to the other units. This is how you need to write 1,4 adduct. Hope you understood. And that's what we are talking about. Neoprene, isn't it? Alright, simple question. So right answer is B. Lysine test, detection of extra element. You guys can see both nitrogen and sulfur are present. Which of the following is the blood red color with Fe plus 3? See now, what will happen in lysine test? Lysine test is meant to detect the extra elements in the organic compound. Let me just give you a glimpse of that. What will happen in the lysine test? You will take a very small crucible, small test tube is called as crucible, and that is taken the organic substance, whichever you are detecting the extra elements for, small amount of freshly cut sodium, put it in and heat this entire crucible, glass, very thin glass test tube, smaller one, heat it red hot and put it as it is in the boiling water. Boil for 15 minutes and filter it. Remove all the glass pieces which are made from the crucible. So what will happen? The filtrate is supposed to have sodium you have added. Organic compound certainly has carbon. If it has nitrogen and sulfur, the filtrate will form an ionic compound. When you have heated such high temperature, all the bonds in the organic compound would break and they will form thiocyanate, right? Sulfur, cyanate, CNO minus. It's an ionic compound very much soluble in water. This is actually present in our filtrate. Now this filtrate is added FeCl3 solution by us externally. From outside we will add FeCl3. If your compound has nitrogen and sulfur, these two elements put together, then these two will react mutually to produce FeCNS or SCN, doesn't make any difference, taken thrice, plus 3, which is a blood red color precipitate. So formation of that blood red color indicates that there is nitrogen as well as, brilliant answer beta. Don't be mistaken as this. This is a detection for, there is no sulfur, you guys can see it is for nitrogen. And this is for sulfur as well. Sodium sulfur nitroprusside. This is for detection of sulfur, this is for detection of nitrogen. This is formed, this is not the precipitate, this is the precipitate. So slight confusion could make you end up here. Could make you end up here if you don't see nitrogen properly. Everything is known to you, but mistakes will be silly mistakes. Timothy gave brilliant answer. So as Bhavani Prasad Haru, brilliant, excellent. Look at this stoichiometry, organic chemistry based question. Weight of 2 moles of the organic compound which is obtained by heating sodium ethanoate with sodium hydroxide in presence of calcium oxide. What is that? Sodium hydroxide and calcium oxide mixture referred as? What is that referred as? Where is it used? Strong alkali mixture. What is that called as? Speak out, buddies. What is this called as? Waiting for your answers. Soda lime, isn't it? Isn't it? What do you say? Bhavani Prasad, is not soda lime? Yes. So what is happening here, if you take the sodium salt, you guys can see that when I am taking the 2 moles of the organic compound, alright, weight of 2 moles of organic compound which is obtained by heating sodium ethanoate and sodium hydroxide. Yes, when you have heated with this mixture, what will happen? You will be eliminating carbon dioxide, and what is by giving or asking the questions in a different manner. So when I mentioned that as the sodium salt, then we got a little bit fumbled. So this is nothing but the soda lime, and what is the gas which is obtained out of this reaction is nothing but methane. And how many moles of this methane is obtained? 2 mole. And you all know that mole is nothing but molecular weight, isn't it? Mole is molecular weight. So when I multiply this with the molecular weight of methane, what is that you are getting? So how many gram of methane is obtained? The answer is 32 grams. Have you understood? Yes, brilliant. 32. So first of all, have you ascertained that it is methane, Haru? You understood, right? Because this is nothing but decarboxylation. Good going, buddies. Good. Brilliant. Chalo. Tranquilizers. And frequently asked question, barbiturate. Or sometimes it is also mentioned as barbital. If they mention this as barbital, probably you will make out that all, and that is the reason why they gave it as barbiturate. Can you see the beauty of NEET questions? They are actually referred, deleted. They are referred as what? Barbitals. All you will match. That's the reason why they mentioned it as barbiturate. And we need to know a small thing related to this. Always remember, they are non-narcotic and sleep causing. You guys are into BPC, I mean biology as mainstream, so it is always good to know about it. Okay, 2 examples which you guys have to understand. One, barbital, vironal, combutal or amytal. These 3-4 examples I want you to make a note. Okay, you can't take any chance, I told you. These are there in the other entrances, so let's be prepared for the worst. Alright, now electrochemistry. I think it is there in the syllabus, Bhavani. Alright, let's see. Conductivity. You need to know the difference between conductivity and conductance. Conductivity is something that is defined per ml of the solution, 1 ml, 1 milliliter of the solution. Whereas conductance could be per mole or per equivalent. So remember this, don't get confused. Conductivity is represented by the symbol K, kappa. Alright, so conductivity of centimolar solution, that is 1 by 100 molarity. This is all extra information at times. Extra information will be given to you so that you get confused. Their intent is always to confuse you. So look at this solution's conductivity, 0.0210 ohm inverse and centimeter inverse, and resistance is 60. What you need to understand here is to find the cell constant. What is cell constant? You know the formula, isn't it? L by A. The ratio of the length and cross-sectional area of the medium, that is volume of the solution. Length into cross-sectional area is S. Okay, L by A is nothing but cell constant, which is equal to K by C, where C is the conductance. You can otherwise write it as K, 1 by conductance is nothing but resistance into resistance. That's all. Very important concept. You will be given 2 different electrolytes in the same solution. Once Kr will be given, seconds K will be given to find out R. Remember, this is very important. This is cell constant. Sir, what are the other type of questions that are asked? Let me tell you, other type of questions. This is since constant. You can write this equation as what? K1R1 equal to K2R2. You may be given entire information to find out any unknown. So be careful. This is a simple question though. Alright, just substitute. What do you get? K is 60. Alright, buddies. And R value substitute. K is 0.0210 and R value substitute. Looks to be that we will be getting how much? 1.2 0.26 centimeter inverse. Isn't it easy question? Right? Electrochemistry, we should not be afraid because difficult question may be asked. No, sometimes they could be just formula substitution oriented, and mostly electrochemistry means formula based questions. So don't ignore, don't be afraid of this physical chemistry. Organic, when we look at the reaction, we might initially fumble, what could happen during the reaction. It's not a sequential reaction, it's only one step reaction, because first step product is anyways given. What is that formed? Cyanohydrin, isn't it? What do you guys say? Alright, addition of HCN to aldehyde of ketone gives rise to cyanohydrin, no? Isn't it, Varshini? Now these cyanides, that cyanides we have studied, very dangerous compounds, no? Upon hydrolysis, gives you carboxylic acids. Now this is where you have ended up, right? Hydrolysis gives you what? First, carboxylic acids. Is this step understood? Now, sir, why are you writing carboxylic acid? Because you see, there is no option pertaining to what? The cyanide in the given any options. And you see, you have added H2SO4 and you are heating it. You know that concentrated sulfuric acid will act as a very good dehydrating agent. That means it will remove water wherever it is. This is a very strong, what it is? Dehydration agent. So what is going to happen? It's going to remove water. So from where do we remove the water? You can see that carboxylic acid should be there, isn't it? Now we have only two options related to that. These two are anyways ruled out. Got it? Now look at this. When you have these two options, dehydration, that means removal of water from the substance, is going to give you a double bond over here, because the product obtained is conjugated. Can you see that the product is stable? COOH is formed. Yes, you are very much with me, but slight confusion looks to be, isn't it? Have you understood? How do we get to this answer finally? Varshini, can you hear me? You can see the options are pretty straight, clear. Alright, so this is we are going to work out. If you have anything else in your mind, so why should not be this, that, etc., you can ask. I am waiting here for your questions. You can post your queries in the comment section. I can read it and I can reply to them as well. So you can say, sir, why this, why not this? Yes, you understood, Timothy. Great going. You guys can make out that you can score cent%. Homoleptic and heteroleptic. Homoleptic means what? Same ligands. Opposite to this would be heteroleptic. Different ligands, n number might be present. Names are given. So this is in a way test for your IUPAC nomenclature also. Not audible, Anjana ready? Am I audible now, beta? Can you hear me? Can the other students hear me? If you could say yes, that means she will correct her voice settings. I'll give you some time. Please check yourself. Yes, audio is clear from my end, Anjana. Could you please check yours? Chalo, good luck. Now listen, beta. Homoleptic, I said. Homoleptic, heteroleptic. Homoleptic complexes are those in which only one type of ligand present. Like you can see K4, FECN, taken 6. You guys can see that there are only cyanide ions that are present as the lone pair donors to the iron. Nobody else is there. You see, this guy is crazy. Haru gave the answer by now. What about the others? Varshini gave twice. Okay. Let's check. Heteroleptic also, let me complete right, because it's always good to know what are what. Different ligands are present here, so heteroleptic. So you guys can see potassium trioxalato-aluminate. So you have potassium in it. You should also know how to write the formula based on the oxidation number. Potassium, aluminium and oxalates are How many? C2O4 oxalate, isn't it? How many are there? 3. So total charge 3 into oxalate is -2, -6, and aluminum is +3. So this whole unit has -3 charge, hence we require 3 potassium to compensate. Good. You can see there is only one type of ligand, whereas here diamine, that means 2 ammonia. Alright, chlorido, nitro N means you know that NO2 is an ambidentate ligand. The donor can be nitrogen or oxygen. Platinum 2. So this is how you can see in all the other cases, pentamine, carbonato, there is amine, there is carbonato, triamine and aqua. So right answer is simple, isn't it? You guys are doing really great. Just imagine these questions are asked to you. You will literally rock, isn't it? The relation between the Nm, what is Nm? The number of permissible values of the magnetic quantum number. You see, this is your second question from the atomic structure. Atomic structure, why is it so important? Because it not only covered in chemistry, but also some questions were there, like ma'am was discussing some questions on Rydberg equation and all that. So that comes in physics as well, right? So thermodynamics, atomic structure is important for physics as well as chemistry. States of matter is anyways deleted. Alright, now Varshini gave the answer also. So you know that the values of the magnetic moment quantum number varies from -L to +L, and you write the total number of values would be 2L into +1, like you have studied, isn't it? It's a crazy, isn't it, right? Going super fast. That means if I take s orbital, L equal to 0, so I can have only one m value. That is why it is spherical in shape. It doesn't have the any other orientation than spherical orientation. When L equal to 1, p orbital, the nm equal to 2 into 1 plus 1. There are 3 possible orientations, px, py and pz. That's why 3 orbitals you draw in S. Likewise you write. So formula would be nm equal to 2L plus 1. So 2L equal to nm minus 1. So L equal to n minus 1 by 2. Brilliant. Brilliant. Excellent. Good going. Come on. Keep it up. But only 4-5 students are responding. What about the others? Anjana? You guys can do, isn't it? These questions looks to be pretty simple. I am there to help you for this next 10 days to accelerate your score as much as possible. Power play, last 10 overs, we will hit 6s. Don't worry, we will win the match. What do you all say? Timothy, don't say that I don't play cricket, sir. The stability of copper plus 2 is more than that of copper plus 1 in the aqueous solution. You see, in specific, let's understand, sir. So why do we have to mention the aqueous solution? Because if you are not considering in the aqueous phase, copper plus 1 is more stable for the reason that it has 3d10 electronic configuration, isn't it? It's completely filled orbitals. But in aqueous solution, you know that when a cation is formed, immediately it is surrounded by the water molecules because opposite charges attract. This you guys have studied as hydration. Oxygen gets attracted towards the positive charge on the copper or any species which is getting dissolved in water and thus chelating this complex, stabilizing it, giving it a kind of consolation. Okay? Yes, you will score definitely, Varshini. That's my promise to you, buddy. What 120? 150 teddam. Okay, beta? Bhavadaridram enduku? Why do we have to think low? Why don't we think big? Because if you think of luxury, necessity is taken care of, isn't it? Let's try our best because these 10 days might change your fortunes forever, isn't it? Alright, so let's see, this is how it goes, right? So we can say that when we talk about the amount of hydration, it is directly proportional to the charge, inversely proportional to size. These two factors are greater for what? Charge is greater for copper plus 2 as well as size is lesser for copper plus 2. Whichever has more positive charge will be smaller in size, isn't it? So we can say that way, and we understand that copper plus 2 gets better hydrated. So in aqueous medium it is more stable. So right answer is hydration energy. Good. Taking stability as the factor, which of the following represent the correct relationship? Can anyone tell me the logic behind this question? One important concept which will come as the abbreviation of your examination which you wrote recently. What is that? Which exam you wrote, Varshini, recently? Board exam, what it is called in your state? I don't know which state you belong to. Which state you belong to, Varshini? Inert pair effect, that is IPE. Inter public exam results are due tomorrow, isn't it? Good luck to you all. But that doesn't matter even if you score 999 unless you are a great scorer in these exams. AP. So inert pair effect. What it is? Here you can see third group element is being spoken about. As we go down the group, especially boron, aluminum, gallium, indium and thallium. When it comes to thallium, you know that the 4f orbitals are going to show very poor shielding, isn't it? We have studied, right? This shows very poor shielding effect. Because of that poor shielding, nucleus of thallium will hold these two electrons very closely to itself. Nucleus of thallium will hold these two electrons very tightly. So these electrons, even if they want, they are not going to participate in the reactions. They are close to the thallium. That's why it's called inert pair. So poor shielding leads to inert pair. So as we go down the group, when we talk about the stability of +1 oxidation state, it increases. Boron has less stability than so on. So highest stable is thallium in +1 oxidation state. In +3 it is opposite. Alright. So you can see that the stability of +1, I don't know how come you made a mistake, Lahari. It's a simple thing, isn't it? So right answer in the beta, option D, isn't it? Shall we move on? What do you say? Next. Move on to the next question. Alright. Chalo. Heterogeneous catalysis. Homogeneous, heterogeneous. Heterogeneous means different physical state. Alright, look at the options and tell me what is the answer. Come on, you got 4 marks. These 4 marks are very much with you, buddies. Tell me, I'm waiting. Read these statements. Make yourself engaged. Who says online is a bad platform? Prove that online is the best platform. Yes, Varshini gave the answer in no time. Excellent video. You read it and you got it. Timothy, see, you read it, you understood it and you marked the answer in less than 1 minute. That's how it goes. All you have is only 1 to 1.5 minutes. You have to read, understand, execute. Mentally you should be very, very strong. Oxidation of sulfur into this thing in presence of oxides of nitrogen, that is one option. Hydrolysis of sugar catalyzed, you can see, is this. Alright, you can see all are gases, no? Nitrates, oxides of nitrogen are gases, SO2 is gas, O2 is gas. This is all occurring inside water, homogeneous. Over here, ozone decomposing in presence of nitrogen, all are gases. However, here Haber process of ammonia synthesis, you can see gaseous reaction cannot be done until you take a solid platform buddies, because you need to absorb the gases on the surface, otherwise where will they sit? They require a surface to sit, no? Adsorption. If they don't sit on a particular pan, how would they react? So these reactions cannot be homogeneous. They have to be what you call heterogeneous. In that you can see finely divided iron leads to the formation of what? Molybdenum, promoter, iron, catalyst, etc. etc. You have studied, no? Haber process. Simple question. The number of sigma, pi, lone pairs in pyridine, pyrrole, very frequently asked two compounds. Pyridine, pyrrole. Please make sure that you remember the structure of all. Can anyone help me with the answer? Pyridine is a replica of benzene in structure, but it is heterocyclic aromatic compound. Aromatic. You know, aromatic has 6 pi electrons and a lone pair as well, and the remaining bonds are hydrogen atoms. Alright. Okay. Facing organic chemistry. Yeah, it's not difficult. What I would suggest you here to focus on few important chapters. Let me tell you, Varshini. One is general organic chemistry, beta. Acidity, basicity, stability of free radicals. Second is isomerism. Third, alkenes. Fourth, SN1, SN2. Alright. Fifth, alcohols, dehydration and iodoform test. Sixth, aldehydes, ketones, condensation reactions. You read these topics exhaustively. Alright. You can drag on and the class gets over and you can make down the note of what topics I said. Is it okay? Chalo, you can see now someone gave the answer. Bhavani Prasad gave the answer already. Yes, let's check. You know how many lone pairs are there? So when one lone pair, two options are ruled out. This is how you should solve. Remember this. There is one lone pair, these two options are left. And then pi bond, you go for the pi bond. How many pi bonds? Why you are counting sigma bonds? Isn't it sane? Isn't it insane? Why do you have to require sigma bonds? What is? Why don't you count pi which are lesser in number? You can see this. So why do I have to count this? Anyways, you can see that this option clearly indicates. So always put least effort to get the best answer. Don't sweat around. You will panic. Have you understood the technique now? Lone pairs and pi which are lesser in number must be counted first. Finished. You got the answer, no? Easy technique. So some people, no sir, I want to count the total number of sigma bonds, sir. I from the pain or nana. You'll be unnecessarily tired. Are you understanding? So look, theoretical question from the intermediate textbooks or basic NCERT textbooks, isn't it? You guys can see. Could you please tell me, fatafat, what is the answer? Theory question, buddies. Bhavani, speak out. What's the answer? Waiting. Lahari. Yes. Sigma 1 is, isn't it not? Nitrogen, no. You can remember this way. 2 1 2 1. If electrons exceeds because of the repulsions, these orbitals go this side and interchanging of this occurs. It's called as p mixing. Alright. Theoretical question. Statement based theoretical question from the Henry's law. Liquid solutions. Helium is used to dilute oxygen in the diving apparatus. You know that helium is added. That's correct. Helium gas has high solubility in oxygen. Is it? You know that helium and oxygen both are not what you call correlated to each other. It's not high solubility. Alright. Correct answer. Brilliant, Varshini. Next. For a certain reaction, the rate is K into A square into B. When the initial concentration of A is tripled by keeping the concentration of B is constant, the rate would be. You have one equation with you. Okay. Oh, you got the answer. Super fast. You can see that what will happen if I am just tripling this. 3 times of A all right, whole square into B. I am not changing. You guys can see I will write this as this will become 9 K into A square into B. This is your older rate. So rate increases by 9 times when alone the concentration of A is increased by 3-fold. That's a brilliant answer. Good. Hope you understood. Identify the final product of the reaction. What is this reagent? Come on, speed up. What do you call that? Clemmensen reducing agent. What it does? It's going to convert the C double bond O group into the CH2 group. All right. So you guys can see C double bond O is converted into, smashed away. Only the C double bond O's are converted into CH2. You guys can see here. What's the answer? Whereas in the other cases, alcohols are obtained. This can be achieved by using lithium aluminum hydride. Is that clear, Varshini? Clemmensen reduction, very important, isn't it? All right. Okay. Which of the following reaction will not give primary amine? Amines, one of the most important chapters. All right. So let's see. Amines, isn't it? Okay. See now, Hoffman bromamide reaction, one of the most popular reactions. Hoffman bromamide, elimination of CO. That means the product is methylamine. All right, the product is methylamine. Lithium aluminum hydride would be converting the cyanide into primary amine. You got primary here, sir, you got primary here. Isocyanides, you know that nitrogen is in the middle, no? You got secondary amine. And lastly, lithium aluminum hydride on this will give you a primary amine. Remember this is not going to give you alcohol unlike the esters. This is going to give you primary amine. This is one very special reaction. Only amide does this. Is it understood? Okay. So this is how it goes. So what is the right answer for this question? Option C, right? Will not give primary amine. You can see option C. The compound is giving secondary amine, but is all right. One question from the gaseous state. Now you will say, sir, removed. It's there in physics. Let's learn that. Okay. So you can see which amongst the following is the correct option. Now when we draw P versus, this looks to be very tempting and we get immediately tempted to say, sir, this is the answer, but you forgot here. Here in this graph, this one with the higher slope, higher temperature. But you can see opposite of that is given. So this cannot be the right answer. So how would I get the answer then? PV equal to nRT. P is equal to nRT, all right, into 1 by V. So y equal to mx. So it's a straight line which is passing through the origin. P versus 1 by V is a straight line. So this is wrong. P versus 1 by V is a straight line. And top of it, you can see y equal to m. So slope is nRT. You can see more the temperature, more is the slope. You guys can see more the temperature, more is the slope. It is perfectly matching. Correct answer, Lahari. Brilliant. What an answers, buddy. बेटे मैं तो आप लोगों के कमेंट नहीं पढ़ पा रहा था, सॉरी. नहीं, ऑनलाइन वगैरह यहीं पे पढ़ लो 10 दिन में, ठीक है बेटे. ऑर्गेनिक केमिस्ट्री वट एवर आई मेंशन सो फार आर सफिशिएंट बेटे, ठीक है. तो ये देखो, ये तो मजाक है भाई. दिस इज अ कॉमेडी, इजंट इट? बिकॉज ये लुईस एसिड इज समथिंग दैट व्हाट is going to accept the lone pair, right? It has electron deficiency. Lewis acid, you know that this has completed octet. Valence अभी तक हम लोग पढ़ रहे थे. And this has a completed octet. This has a completed octet. Whereas this boron has 3+3. You know that it has an empty orbital. So हम लोगों ने काफी हद तक पढ़ा ये चीज. We have studied this long back, isn't it? Okay. So catch me here and I'll help you, Mani Sampath. Okay. So let's see the last question of the day. Tomorrow we'll come up with more questions. 20 to 25 questions are sufficient, isn't it, Ratna? What's the answer to this? Chalo, I'm waiting, buddies. C. Baapre baap, you give so fast answers, Ratna. Rasagna. Acha. Rasagna, you are the one who attended my classes over online platforms. Acha, there are 2 simultaneous chat boxes going on. No, right? So what is the answer? Some people are saying C. Ratna said C. Lahari said C. Timothy. You see, yes, you did not. Maybe it is some other girl with your same name, isomers. So now look at this. The element expected to form the largest ion to achieve the nearest to noble gas configuration. Largest, you know that the sizes when compared, the species with the negative charge is expected to be having more size, because size has to be compared with respect to the effective nuclear charge, not with respect to the atomic number. Whichever has more positive charge will be smaller in size, more negative charge will be larger in size. So in order to achieve the noble gas configuration, this takes 2 units of negative charges. It will become 10 electron species. Fluorine becomes 1. This loses 1 electron. However, nitrogen takes 3 electrons to become a noble gas. So more the negative charge, more is the size. More the positive charge, less is the size. That's how. Don't get confused. Please read the question properly. If you read the question, let me tell you, you'll get the idea. You'll get the idea, you'll get the answer. Read, understand, execute. Don't be in a haste. Alright? So, daily we will be attending the sessions, learning something new, and good to see a lot of students have joined to this session. Hope to see you with some more interesting questions in tomorrow's session. Same timings. Stay tuned. Alright? Thank you.